one of the main purposes of this meeting is to think and talk about the testing framework and discuss ideas. So please don't be shy. If not, we can go and discuss other following topics. Have we discussed the recent data inconsistency that was discovered? I don't see it. Oh, maybe we did. Is this the one? Yeah, this is the one. Okay. So yeah, we've discussed the data inconsistency. So if there are no other questions, and I don't see any new issues related, I think we can just follow up with the test failures. I see a lot of triaging done on the QPS issue. I see. Or there are two types of failures. I assume Ahmad, did you triage the issues or? Okay. Don't know if Ahmed can talk. Okay. So yeah, like last time, we normally go through the dashboard with the failures and try to identify any trends, any new failures, so that we can keep an eye if there was anything that was merged that has introduced a new failure. But from what I see, or what was the triage we have, most of the issues are QPS issues with two progress notifies. QPS issues are expected to be caused by the defrag, like introduction of defrag in the etcd robustness tests, and we still haven't addressed it. The progress notification does not match. Usually comes from the fact that if etcd is too strained, it doesn't guarantee really that progress notify will come in. So we don't have really a good way to test it. Like it's an optional feature or optional. It's a feature that gives you best effort notification about the upgrades. So it's hard to test correctness of something that is best effort. Like if it comes, then we can validate. But if it doesn't come, how we know if they were correct? How do we know that we even tested any progress notification? So yeah, I think from last meeting there was, or I don't see any last changes from last meeting about the QPS issue, and Ahmad was like, we were looking at the performance graphs on if there is a notion that we run out of the resources. But I think, assuming the current performance, maybe we should just lower our targets. Lower our targets. So here we either reduce the number of required QPS, or we can reduce or make robustness test less intensive. And I think I'm mostly for thinking about the second option. to reduce the number of defrags that we do, or maybe limit them. Back, do you have a question?
And just out of curiosity, do we know the source of the quote unquote flakiness? Is the number lower because is it because of the internals of the SED or is it because of the infra that is running it under? Uh,
Uh, so I didn't maybe catch the first part. Do you you're saying it's either HDD defrag or what?
or is it because of the environment that we run our test in? Is our environment separated enough to provide
I
a
mean,
guarantee on performance?
if we had 100%, if we were 100% sure, we would address the cause. If we knew where is the cause, we because like even if you look at the dashboard, this is, let's say, every day we run 100 times 120 cases of the test, or like random test case. We run 120 random test cases, and we see flakiness on one or two scenarios per like those. So it's still below, like I know, I assume 5%. So it's this makes it very hard to spot trends. If there's a trend that says, "Oh, the performance of architecture has decreased," it's very hard to say because like we would either see consistent errors or a change or not. So this is like level of, it's very hard to guess. It's very like the failures are very random. And on the side of defrag, like uh, the only thing that we can base it on is fact that before introducing defrag, the tests were, or if I remember correctly, because the defrag was introduced before this meeting has started, and we started like proactively keeping notes on the robustness failures before I just like did it myself once a week, did the triage. Uh, so we still don't have a 100% guarantee because it's also not a case that, oh, we looked at the dashboard and we introduced defrag and we see the day before everything was okay, the day after it was not. So here I just prefer going with the option that is more like more in a solution that is more maintainable or more on our side, and on our side, and instead of like trying to find to debug the performance disk on architecture of the infrastructure that we run on.
Hmm.
We it's that seems, at least it seems harder. I think that the solution or high level problem here, my suspicion is that it's the fact that we just run on pro runs tests on pods, and those pods don't have any disks allocated, special disks, so they are just running on like normal Kubernetes on normal nodes, and they don't have, and they are just using host disk.
Hmm.
And if this is any like normal cloud, that would be a boot disk, and boot disks are just a normal HDD with minimal disk size. So like going back, we cannot expect to get a good performance from them.
Right,
And if we would try to solve it, like for example, request mounting for HCD, mounting a
right,
special PD SSD that you're expected to run HCD in production, the answer would be no. Like the cost, like I know the cost of PD SSD is non-trivial. It would be at a significant cost, like even comparable to the whole like VM. So double, or we would ask them for double or triple our costs,
I see.
and would
Yeah,
require non-trivial engineering. And I don't think it's something that even Pro by default maybe Pro supports.
That makes sense, and but maybe for the nature of it, it is probably easier to under promise, and when they have a dedicated machine, then it'll probably perform better, rather than having us have a dedicated machine and get the exact number where the running environment could also be a shared machine, right?
Mm, yeah, yeah, like something like this. I mean, we need to be aware of the costs. If
Gotcha.
one of the goals of robustness was we should be able to run CI, we should be able to run pre-submits to catch regressions, and we should be able to um, I would say run constantly the tests, like run all the time and qualify things run for as much hours as we can. This, if we hit the if the current performance set is too high, maybe we should remove, like reduce the defrag. I think that, yeah, I think the problem was I was too optimistic with enabling the defrag. So currently, I think or because it's good enough for on my, or like if you run on your hardware, it was good enough, like for like if you run on normal hardware on your local machine, this is not a problem. But if our target is the cloud, we should or continuous integrate CI, then requesting a dedicated disk is somewhat non-standard option.
I see.
Um,
Thanks.
yeah, the only problem is like if it's a question how low we need to put the defrag. I see two solutions. One is reduce the probability of running defrag, and second one is restrict to defrag to be, I know, happen only once per X requests, or X some period of time. It's hard to say, or is it hard? I would need to read reports. It's hard to say what number we should target, because like probability, I think at the end the second solution would be better, because if you look, maybe the reason that there are random failures is the fact that we currently randomly execute the defrag, which means the uh, if we are unlucky and there are multiple and there is a congestion due to multiple defrag requests, maybe that this is causing an issue with this is triggering the flakes. It's not, the flakes are not because of random hardware issues or like congestion, because we checked the performance of the machines, or at least resources last, thanks to Ahmed. He found a dashboard for Pro. Where is it? Mm. Yeah, we can like look at some random job from, oh no, this is Pervdash. This is what I've been proposing as an alternate, or how to tackle the problem. Yeah, so you can see how much how much resources we use on like some recent job. So we can see we are using around, like, 2 gigabytes and 1.5 cores of CPU. And where is the and resources allocated should be much higher, or this is better dashboard. So if we zoom in on one of the jobs, there is like no chance of memory pressure. Like we are using just 1.5 gigabyte and requesting 14 gigabytes. And same for CPU. We have some burst of CPU, but then there is some like constant usage. The burst is interesting. Yeah, I'm not sure why there is a or the burst would okay, that would be as some compilation of a couple of things. We have non-trivial. We are compiling a couple of things there, and that could be using resources because it paralyzes well. Yeah, so I would say the recommended solution would be to instead of having a random diffrag, have a where's the I had usually a section on usually in test. Maybe we lost it, but we on the want this section to copy. This, and we should prepare a solution. So I would say the goal would be replace random diffrag execution with what would be random with a periodic one. Period should be based on current average number defects in test. Yeah. So that would be my how I would approach the solution. Is there anyone interested in working on this? Okay. I mean, if not, I can just try to implement. I mean, we can try to implement it. So, Bike, you have still your hands up. Do you have any questions, or was it left out from the previous?
I'm good.
Okay. I cannot. So let me open etcd code base, and maybe we can try to do something. And just making sure that I have a clean environment.
By the way, I hear you typing, but I don't see anything changing. Is it a different screen?
Yeah, just wanted to make sure that I have a clean setup.
Gotcha.
Okay, this should be working. Can you see my screen?
Yes.
Okay. So I previously did an overview of robustness test, but we can quickly jump to the problem and try to solve it. So defrag is, or sorry, have I mistaken? Been talking all the time about defrag. I think I meant compaction. Do we do defrag at all? That's also a good question. We don't. So yeah, sorry, I meant compaction here. So we, that's, okay. We also have defragmentation. We run the fragmentation, but I just let me show his. Can I put a find references? Where is find? Oh, it's, yeah, IntelliJ doesn't. It's useless when it starts. So we have, I'm looking for the symbol. So we have the fragmentation at CD. It's implemented, but it's not used. Okay. Find usage. Oh, it's still updating indices. Okay. So we have definition, but we are not using the fragment. And this is in etcd. We don't have. Oh, I hate it. Okay. So here we have Kubernetes, or here we have the failure of etcd. So we assume, or here we have etcd. In both cases, in etcd we have compaction with weight of 2, and because we have sum of weight to equal to 100, so for probability this means 2% of request, 2% of request should be in compactions, and here should be similar. But here should be similar. We have some, but the sum of weights is bigger, so we have 1,000, but we compact every 25. We have weight 25, but it still means around 2%, 2.5% of compactions. So the goal for today would be to re-implement it, to not run, change the right choices to something like compaction period. So I wanted to check the defrag because to make sure that if we are not defragging, then in both cases, even though it's implemented, that we could then the make sure that the here the issue is with the compaction. So we can still like propose some compaction period, which would be time duration. Similarly for etcd. But this is so this is traffic. Oh, this could be annoying. So we should. Oh, and we had cases where we avoided compact. This is, I don't remember. Oh, I haven't read the code for some time, apparently. When we disabled profile for bit compaction. So, yeah, I see I had the previous mitigations. So previously, oh, okay, so this is for bit. Okay, that makes sense. So there is just one case where we forbid compaction when we don't want to compact. It's basically, if we have a test that injects a fail point on compaction, we don't want to have both periodic compaction and executed and injection when we inject a fail point. So when we test the compaction, like when we test a fail point, so we inject a fail point in the compaction itself, we don't want to at the same time execute it. So that should be okay. And I assume we will need, so this is a traffic generator for the etcd, and it starts all the client, or it starts one client. So here we run the traffic on the client. So this is one function, and that is executed. Again, IntelliJ is not indexing. We need to wait. Unfortunately, it's too hard to be able to find a name run is too generic to be easily discoverable as an interface. So what I'm trying to figure out, what is the best place to plug in. So high level, the flow should be, we prepare the test and we call simulate traffic, and simulate traffic runs all the clients concurrent. So what I would want to do is reserve one of the clients to, or maybe introduce an additional client, because technically it's not doing anything. So, have one more client. Just sorry for the noise. I don't know how to silence the noise with the IDE. It just fails. We want to have one additional client, and let's say it talks to all the endpoints. You should still think about maybe adding some clients that talk to all the endpoints, because we had failures or load balancing, or there is discussion on one problem with client load balancing on correctness. So, and instead of run, we would run, let's say, run compact. It's still just in work, and we will, like any other client, we would adjust. We would in those cases we are preparing the clients and running the compaction and adding reports later, and we would test. So add one more wait group and execute compaction. So we just need to implement run compact as a function. So if we look at the run, it's a interface over different traffic profiles. So do we really need a different traffic profile? So because we defined the, maybe we should instead move the, this is profile and traffic. Sorry. Instead of having it as a specific to traffic, something that's specific to traffic, maybe we can just do it as a generic field, and instead of having it as a and have it just a function here. How to best to do it? We can just copy. This is And if it's generic to the traffic profile, you can have, should it use the same rate limiter? I would assume so. Do we need unique ID for the request? No. We don't need any lease. We will not create any leases. And compaction, technically, this is like also like concurrency limiter, so that we don't do a lot of concurrent deletes for linearizability or don't do too many concurrent writes. This is for linearizability. It makes very hard to linearize history if there is too many concurrent writes, concurrent non-unique writes. So writes we, for example, don't have a unique key or don't make a write unique value, or so. Maybe let's use it just in case, because we for maybe in first iteration we will not want to guarantee we will not want to make compaction unique. And what I mean by this, maybe we could, the revision that we pick could be random. So, or we will just pick some revision and we will not, or we'll see. So yeah, we don't need this last revision. Maybe we'll need this request type. We will not need this. So when we, yeah, this logic we can kick out. So here we have a client and client. Why recording client? We cannot. We just want to compact as a function. Where is it? Yeah, compact. We just, I know, run compact. And some revision. So the only question is, where do we take so the or maybe let's for now ignore this and leave it as a maybe to do. Let's just compact every sometime. And this is of course because I used the wrong one. What compaction returns response, and yeah, so we have do we care about response? Not. If there is an error, we just continue, and if there is not, we can wait. I don't know why it doesn't want to. It doesn't use the limiter. Okay, so this is unused. Okay, so we have a run compaction. We just need to set a period. So compaction or finish. So run compact period, maybe time duration, and we'll continue to execute the loop. We need some logic to pick revision. Let's say last ref equals 0. Let's say last equals 0. Then we compact and done. What is the easiest way to do this? We should have just another case for time So question, do we want a clock to avoid more leak? We should have a ticker. So ticker, time ticker, new ticker, period. And we defer ticker close stop. And this ticker, there's a difference between timer and ticker. And I forget which is which. Yeah, so I don't like this. The time interval would adjust based on the time, so maybe we just want the timer. So timer. So yeah, this will, it doesn't matter how much. So it's timer for now, and timer C. And so we will just, instead of exiting every, like just falling through the checking if we have finished or the context, we'll just wait. And when we exit, we will fix a revision and then we will come back. And then we will wait on limiter. I just don't want to ensure we don't make a bug time on its channel. Anyone familiar with or remembers? I'm not up to date now. I think this should just write a time every period. I think the usage is simple enough. There are some caveats with resets and things. Or do I need to reset the timer? For timer created with new timer, reset should only be invoked only on the stop or expired timers. Stop prevents timer from firing. Oh, so this fires once?
Yeah, I'm looking at it, go by example, it says timers are something you want to do once. And if you want to do something repeatedly, you want to use tickers.
Yeah, but ticker, if you I have really bad experience with ticker.
Oh, I see.
So ticker has so it's better to timer. Why do you want or ticker will send you things periodically, but doesn't guarantee that it will give you things after a certain time. Because if the consumer is slow, then it will decide to, like you're slow, so I will fire less frequently. And I had this case where we were implementing a consistent reads from cache, and I wanted to have something that guarantees that will send every 100 milliseconds a notification. And ticker just, if you didn't read within because you were busy doing other stuff, the ticker would just increase to 200 milliseconds and 300, and it tries to adjust to the client. So it's better to have a full control with timer, in my opinion. So when the only thing you need to remember is timer. You need to, I think, reset it with period.
Okay. So it was just the nuance of the channels where some of the signals were missing, either due to channel buffer full or whatever.
Yeah, so you just need to make sure that you drained the channel. So because we are
Gotcha.
We create it and then drain, we can read it. Yeah. So we are not resetting it. It should be it just. You just need to remember. So in my case, the effort I mentioned the thing that was supposed to run or execute 100 milliseconds to minimize the latency of some event, it caused it randomly. When you did experiments, we found out that it took like sometimes 300 or 400 milliseconds, and there was nothing else that could have gone wrong, and it's horrible. But the last thing that you think is that you look at is whether you use the ticker correctly. Okay, the question is, how do we pick revision? I see. I would like it to be somewhat based on the ranges of revision available. It should be. So if there is a set of keys, I would like to be some number with it that is sensible. Like if I compact to, or if there were a lot of keys written and my last compaction was very, like, is not catching up, we either compact on the full range or on the range of, I want to compact it from the last, not the latest. We want to test the latest, but not only the latest. So what I would recommend is do a range start and revision. How do I'm oh man, I haven't read the code for so long. I want to read all of them. So yeah, I need to pick up start and what is later. A revision limit. Revision, I want the latest state limit. I don't care. And or there are two differences because okay, let's implement it simpler. Kubernetes has something, a unique algorithm for the, let's just implement Kubernetes revision. I think it's good enough. So you can just get anything, make sure you just get a key and revision. So let's just make a empty get. Does it fail? Oh, it just returns key value. I don't like it. So yeah, I want to get let's just do a range from latest revision on no metric keys and response error. If error is not nil, we will just continue. The only bad thing is if it fails, we will not do a compaction. So that's not great. And let's compact just, we will have range of number from last revision, let's say last revision to response header revision and to random. So or rand, we would get, I don't know, an int. Should we use, we are using rand one. Okay. We would need to upgrade. I want to just use rand version 1 because we modulo or minimal number is the last revision. We don't want to compact last revision or last revision plus 1, and maximum number response and max just for header revision. So to compact the latest. So the algorithm should be max minus min plus min. just for random range max int and we will just say random range, and now like last or maybe last ref equals random range last ref plus 1 resp header revision. So it's both random and we or even sorry, Kubernetes algorithm is more stupid. It just it will first compact the last revision. So here we say last revision. It needs to be at least, I know, number 2. Let's say we compact it, and then resp, and we, yeah, like I totally did it. And in response, we'll get header equal header revision, and we just save it. Okay. Sorry for confusion. Does it make sense? So on the first loop, we'll compact revision 2, and so we will wait, I don't know, let's say some 100 milliseconds, we'll compact revision 2, and then we'll save what revision is the latest in compaction. Yeah, because etcd, fortunately or not, should return us compaction is a linearizable request, which means it should be revision that is returned by it should be the latest revision in the cluster. So we will just say, oh, like this is the last revision. Like we will split history in the period that we will be compact. We will basically, if we set 100 milliseconds for the period, we will be running Kubernetes like compaction, semi-Kubernetes like compaction, but every 100 milliseconds. But every period. Okay, so we have the function. Let's just use it. So we will run compaction arguments. Client period limiter, client period. So that would be, we have our traffic here, traffic. I love clashes in names. Oh, not this traffic. I want traffic profile. Yeah, so it's can be easily misnamed, but I want to. Here, profile. Yeah, the traffic is just the shape, and profile is how much we put pressure or how like throughput. And I know that is independent of the shape of the traffic. So compaction period. We don't need IDs. LM, I don't remember what is LM. This is what? List storage limiter. So we just pass limit. Okay, what else? We want to remember not to run the compaction if forbid compaction, because we don't want to run compaction if there is a fail point. And that's mostly it. We just need to configure it. There is some cleanup to be done. We need to configure it on the profile. So at the same time, milliseconds. I would like to target around 100 milliseconds. Mm, yeah, this is also not exactly the algorithm for Kubernetes. It has pretty one unique thing that could find about this, but it should be good enough. So let's maybe before the goal for today would be just to run this, see if it works. I don't know what etcd version I have locally compiled. So to run this and maybe push a PR. Okay, it runs. Doesn't fail. What would be nice to confirm is I don't remember the name of the argument. So let me look at the README that I wrote, and because I would like to confirm one thing, I would want to configure robustness to generate a report, which is described here. Debug persist results, because I think it cleans up the results or doesn't write goes through. Okay, so what happens here? Did it persist the result? No, because I passed it in bad place. This way, no. So what I'm expecting is I want to check if the compaction is really executed, and can we see it? So now the difference is we've wrote a visualization for the test, and you will not be able to see, but if I open it in my dashboard or on my machine and select this window, you should see that there was compaction. Of course, I know for some reason it doesn't work. Compact. So I was expecting. So there is no. I don't see the run, or there is some executions, but the the graph or the visualization doesn't work good enough. Let me just quickly. We are on the time. If I run it again and show you the results. The only thing I changed is I increased the period of the compaction, and that should be good enough. Okay, so maybe there is a bug or something. It still finds only 2 compaction in all of those requests. There is 2 compactions. There were 2 compactions. Okay, so this is, we can stop here. This is high level idea, or the the work on this PR should give you a high-level idea of what does it mean to work on the robustness test from perspective of, oh, we want to change the shape of the traffic. Let's instead of doing it as part of traffic generator, let's do it as a separate thing, spin up separate routine that will run it periodically, because it, like, we don't have, it's hard to give any guarantees about how frequently execution. We can implement it, then we can run the tests, see the results, and on the visualization of the history, we should see the expected results should be, we should see the compaction, the change in the traffic, and we can verify if the change that we did is really changed how the compaction is executed. And hopefully I should be able to send this. This should be mostly done aside of some small issue, and should be able to send. So that's all. Sorry for taking a little bit long. Hopefully that was useful for you, and we can and you will see the PR next week. Thanks everyone for joining, and see you.